Okay, let's start to do the presentation. Zoom will be the first one, okay?
Hello. Okay. Make it large. Here. Right. Okay. Hello everyone. Today I'm going to present the assignment econometric lab 6. Okay. For the step 1 is it is a theory that I skip it. So I will start in the step 2. Okay. The step 2 is about estimating the basic model. You can see it in the book. This is a estimation of coefficients. The first beta is horsepower, is positive, age is negative, in hour is negative, diesel is positive, FWD positive, manual is the negative, jaundice is positive, spring, summer and winter is the dummy variable. That's cannot how to say. Yeah, sure. Thank you. Sure. For the question B, I saw it's about adjusted R square is 0.685. Yeah, I think this makes it as an explanation for 10 dependence variables. Adjusted R square value is in a normal range. This explains the change caused by having multiple variables.
I think you mean that 10 independent variable instead of dependent variable, right?
Yes. Sorry.
Okay.
And the question C. The question C, none of the coefficients have any unexpected sign. Every independence variable meet the expectation. Yes, like this. So I do it in eView and in the Gretel. In Gretel, you can see about the p-value.
How do you know the Gretel?
Yes.
You mean Gretel?
Yes. What?
So how do you know? How do you know Gretel?
My friend told me because I use MacBook, but by the way, I cannot do it in eView. So when I come to the dorm, I cannot go to the building for do it eView in the lab. Yeah, I think I can use this.
I mean, how do you know how to do this Gretel?
My friend taught me, and I see in the YouTube about the run regression.
Oh, okay.
Yeah.
Is he or she in the IMBA program or
Yes.
or not? So he or she took my class last year.
Yes, I think.
Yeah, I did Gretel last year.
Oh, yes.
Because that's on the internet.
Mm-hmm.
When I go to in the classroom.
Mm-hmm.
So I teach that using the Gretels since we're not able to come to the class, and we're not able to connect the eViews every time. This is a very good program, okay? I love this program very much. It's free.
I love to.
And it's universally, famous package. Okay, so if you all like it, maybe I can show you next semester if you took the econometrics, another course. But not this semester because this is required. Okay, everybody to do everything, which, in our, in the school, was the license. But this one, it doesn't mean that without license because it is free. Universally free packages, statistical package, and is very good. Okay, I can show you next semester if you take econometrics class. I'll show you this one both ways. You can double check and using this one, since it is free program, therefore you can use anytime, even after your graduation. This is very, very good. Sure. Look at these answers. Look at these answers. You can see, huh? Look at this one. This is from eViews, right? This is from Gradle. Look at everything. Active statistics. Although the decimal places is different.
AIC, BIC is different from the
You mean this one? Okay, look at this. AIC is this one, and it's, it really, see, maybe they're using different formulas, but they tell the same information. So if you look at Gradle, I'm sorry. If you look at Gradle's, you just compare those numbers, for every models. You don't compare this one with this one, okay? All the programmers using the different formulas, although we all call it AIC or SIC or something, but maybe they have different formulas or they, using this, I don't know what to say about it, but you can compare the different criteria within the same program. Okay, and this one is really, really, good for all of you since it is free and you can use it after your graduation. And this one is always updated pretty often. And for eViews, if we want to have this license, eViews, and when you update it, you need to pay money. I mean, university has to pay the money. So far, we have the version is 8. But the updated one, I think, is already 12 or 13. Yeah, but all the different editions, there's smaller, very smaller difference. They really change a little bit parameters of this program, but you still can use the eViews 8. Even now it's already 12, but Gradle's is updated anytime. So as long as you they update it, you can download it, again. Then you have the latest version, so which is very good. I used this one for more than 10 years. This is very, very good. I like it. For company, I don't know because I didn't work in the company. But I know this is free. This is free statistical, universally popular packages. Okay. I think especially in academic level. Okay, but I don't know much about the company or something. But even if you use it, the company, you can use that in your laptop, right? So, and it's free, and you will not violate any copyrights or something, but eViews does. Okay, that's the difference. Okay, good.
Okay.
Look at this output. It's really, really similar. Okay? Thank you for showing us this one.
Okay. That I take the result from Gretel because I'm lazy to do. I'm lazy to look the p-value in Excel because I think in Gretel is okay for calculate something. Yes. And it is the result that I get. Okay. For about the question D, I run one side 5% t-test. Yes. Of the independence variables. Yeah. So about horsepower variables. Okay. So we reject and about age variable we reject too. Yes. Engineer hours is reject.
Okay, do the E part.
E parts. Okay. Okay. Yeah, my answer is jaundice is a dummy variable. When the coefficient of jaundice is 0.17254, it means that the cell power will increase by 70.25%. Yeah. So I read in the Google about jaundice company something. I think it can be implied that it's a popular and well-known brand that everyone uses in the agriculture field something. Yeah. For about the question F, I think there are not any problem in the basic model. Yeah.
If you know more about the econometric, like the one we will continue to teach next semesters, then I think you're able to really answer these problems. So
Okay.
whatever you write it here, I just like to know that what you say about it. And according to what you said about it, I think I will know that what we have learned this semester, right?
Mhm.
Okay.
Thank you.
All right. And step 3.
Step T is consider of
Okay. Step 3, go on to the C parts. You know, if we do everything, then I think we don't have time to do it, okay?
for how about the C part. I think it's so hard to me so much. I read it in the textbook. Yeah, I forgot the page. The textbook said that beta 1 greater than 0 and beta 2 less than 0. And then I use this equation to how to say, to calculate.
Okay.
Yeah.
Can you explain to me, just a little bit, yeah. Can you explain it to me that beta 1 greater than 0, beta 2 less than 0? What does the diagram looks like?
It's like this.
Like,
Curve.
so how to say that? How to say that?
How to say?
It's parabolas with mouth downward,
Oh.
like this one.
Yes.
Or maybe you can say, this is what is the U shape, right? This is inverse U shape. Whatever you like to call it. Okay? All right?
Okay.
Go on.
Okay, thank you.
No, you haven't explained that yet.
Okay. I substitute about the horsepower and square horsepower. Yeah, I I take the
you substitute the coefficient
yeah.
of
I
horsepower.
Yeah, I took the coefficient of horsepower and square horsepower
Yeah.
to this equation.
Okay.
Yes, and the result is that is 362.392.
Okay. So
Yeah.
it's
I think it's the extreme maximum because it could be in the top of.
yeah. Since it is
Yeah.
inverse U shape, so it will be on the maximum.
Yeah.
Okay. Okay. D.
Okay. I prefer the polynomial equation because the first one that I think is a r square and adjust r square. Of the basic equation, yeah, I think it's okay. But the polynomial equation is better because it's close to 1.
Is what?
Close to 1 degree.
Course to 1.
Close to 1. To close.
Close to 1.
Yeah.
What close to 1? R square close to 1? No, the basic adjusted R square is 68 something, okay, percent.
Yeah.
Then it's increased to 76. So it's adjusted R square increase.
Mm-hmm.
It is not close to 1.
Oh.
It's still far away from 1.
Increase. Okay. Yeah, it can be implied that if you're adding more variables, it has a significant effect to the model.
Mm-hmm. Okay.
But I would like to ask you,
Yes.
if there is, how to say, is the value of r square and adjust r square close to 1 is good, right?
What do you mean by close to 1?
Close to,
You mean, do you think 0.76 close to 1? No, 1 is 1, right?
yeah,
This is
0.
76%. So like 3/4.
Mm-hmm.
It's not close to 1, it's only 3/4.
Yeah, around 3
Right?
Yeah, yes.
But it's 10 to the 1 side, the side of 1. Okay?
Okay.
So I think you're not able to say close to 1. If you have 90 something, then really close to 1, but it's only 76. But it doesn't mean that 76 is low. No, it doesn't mean that. Okay?
Mm-hmm. Okay, I got it.
So the point is to compare these two models, adjust the R square, how it is from 6 to 8, 68, percent increases to 76, which is big change.
Okay. Oh.
Okay.
Thank you.
All right.
Thank you. And the second one, I think, is the information criterions about AIC, BIC, and Hanna-Quinn. How to say? When the value of each criterion decrease, yeah, I think it's have a significant effect to the model. Yeah,
Okay.
it's good. So that's why I showed polynomial equation.
All right. Then step 4. Okay, B.
Yeah. The first one is a theory. Yeah, the cap has effect on sale price. The price factor will be high if the tractor use the cap.
Mm-hmm.
And about the t-test, the value of t-score of the cap variable is 6.796.
Well, excuse me. Do not use equation. Do not use the equal sign here. This is not equal. Do not use this equal sign. It's wrong.
Oh,
Okay, you need to use that. How to say this one?
oh,
Dot. Yeah. How to say that?
common.
Just dot dot. How to say that?
Colon. No, colon.
Double dot.
Colon. Colon.
The one with one dot, and this one is we call it semicolon, right?
Yes,
And how to
colon.
say that? How to say this with two dot?
Colon. Colon.
Just colons. Okay,
Yes.
okay.
Okay.
No, you should put the column. Do not put the equal sign here.
Okay.
Okay, this is not equal sign. The equal sign is for equation only.
Okay. Thank you.
Okay.
Okay. So
Alright.
for about the cap variable, I reject it. And the third one is the cap variable is added to equation. The value of adjusted R square is improved.
Okay.
Yeah. So I think it's variable is relevant.
Okay.
Yeah. The first, there is bias.
Yeah. Okay.
Yeah. And this is I added because I think it can how to say specify about
Okay.
this equation.
Okay.
Yeah.
Okay. now, Step 5.
Yeah. Step 5 normally there are 4 seasons in a year, right? Yeah, I think the omitted condition is in the seasonal model is autumn or fall.
Mhm.
That's the professor talked in the last class. Yes. And it is
Let me see. What is omitted condition in this season? So the omitted consists is the autumn. Okay. All right. Summer, spring, summer, winter. Okay. So it's autumn. Okay. Then B.
this is a
Mhm.
hypothesis
Okay.
of this one.
So this is partial F test.
Yes,
right?
partial F
okay.
test.
All right.
And I have one. Okay, for the question D, run F test with the 5% level and calculate it. Okay, first of all, I do it like this as the textbooks because I would like to make sure that the value is the same
Okay.
in the program.
All right.
Yeah.
All right.
So, yeah, I got this
Okay.
value.
Very good.
And thank you. And then
Very
And-
good. This is matched with the result,
Yeah,
right?
yes.
Okay, thank you very much. You show this way.
Yeah, and
Very
then-
good.
and then I use the program evals. Yeah, it's the same.
Okay.
It's the same value that I
All
got.
right.
Yeah, I use word test.
Yeah, okay.
Yeah.
This is what we say the partial F test. Partial F test.
Partial F
okay.
test. Yes.
There are so many kinds of wall test, and this is the one of them. Okay, so you say wall test,
Word
it-
test.
it really mean many things.
Mm-hmm.
But this is also one of the wall tests.
Okay.
Okay, and since we are talking about this questions, usually we call this partial F test. Okay, all right.
So I make the decision is a
Yeah.
reject.
Okay,
Yes.
very good.
Yeah. Yeah. Oh no. Sorry. The conclusion don't reject. Don't reject. Do not reject. Sorry. Yeah. I imply that a seasonal pattern has no effect on the total
Yeah.
price. Yeah.
All right.
And the last step.
Okay.
Yeah. how to say it? I take engineer hours, multiple diesel.
Yeah.
Yeah.
Okay. Which is called
Slope
slope-dummy variables.
Yes.
Okay. All right.
And then the conclusion is don't reject. Okay. The engineer hours diesel variable is not significant because I think the coefficient value is low.
Mm-hmm.
Yeah. Yeah, that's all.
No.
It's low.
I think
It's so
it's not.
low.
It's not because the coefficient is low. It's because the t-value is not significant.
Oh, okay.
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 Do not say the coefficient is low or high because if you don't compare with what is small and what is large, right? The only we can compare is t-statistics.
Okay.
Okay, so according to the t-statistics, the p-value is pretty large.
Yes.
It's larger than what?
Larger than. Adjusted as.
Larger than significant level, which is called alpha.
Oh. Yes.
Significant level. Okay?
Yeah, okay,
You
okay.
need to know those terms. You know, if you can express the terms correctly, then it looks very professional.
Okay.
Right? So the p-value is greater than
The
significance level. Okay?
Okay.
All right?
Oh, yes.
That's it, right? Thank you very much. Thank you very much. Okay, then Harry. Oh, no. Okay, Jackie, right? Okay. Where's Kevin? Huh? No, I mean Kevin. I'm sorry. How many? 15. Well, it's only 15 students. Turn in. Okay. Make it larger. Okay, thank you. Large. Okay, thank you very much.
Hi, I'm Jackie. So I'm going to present the sixth assignment. Should I go of this?
Well, just do. Let me see your result first.
Okay. So my result is like this. The step 2, we saw the cap.
Okay.
Yeah.
Okay. This basic model.
Yeah.
Okay. So, after all the expected sign follow the
Follow our expectation.
expectation.
Yeah.
Okay. Then go on to the E parts.
E parts. Okay. Oh, okay. So my interpretation is like this: if the tractor is produced by John Deere, the price will be higher, and so it has positive relationship with the sales price. And according to the result of the regression, when holding other variable as constant, when the tractor is produced by the John Deere, then the price will increase approximately 17.3 because we need to multiply 100 here.
Okay, let me see the coefficient from your output.
Okay,
So John Deere
please.
has,
Approximately little.
okay,
point.
okay, 17.25 something.
Yeah.
Okay, all right. Then step 3.
Okay. Step 3. So A, according to the statement from the textbook, if the horsepower reach to 1 point and the sales price will decrease, so the diagram will be like the inverse U shape.
Okay.
Yeah, inverse U shape, and it is my result.
Okay.
Okay, and B is test the is 5% one-sided
Let me
test.
let me see your output
Okay.
first. So you put this horsepower.
Is horsepower times horsepower.
Okay, just put a square on it.
Yeah.
Okay. All right. All right.
Should I go through?
Well,
The-
just say something about this.
Okay. So according to the diagram, so I refer to the textbook.
Well, let me ask you this one.
Okay.
For step 3,
Yeah.
okay, we have a before any questions,
Mm-hmm.
then we have a paragraph, right?
Yeah.
What does this paragraph say
Mm-hmm.
about the square of the horsepower?
About the square of the horsepower.
Yeah. What is this?
Mean.
What this paragraph shows? Tell us.
Tell us. It tell us.
Do you have the book?
Yeah,
with
I
you?
have,
Okay,
yeah.
sure.
The horsepower will have positive relation. Yeah.
You can read what's this dealer say? The tractor's dealer say.
Okay.
What does this tractor dealer say? From the second sentence at the second line, he says what? He says what?
The results are promising,
Yeah, then?
but it's very difficult to sell overpowered used tractors
Because?
because Lex tractors waste fuel and provide no extra benefits to the buyer.
So what does that mean?
If the horsepower is too much, then it will like wasted fuel, so people may not buy the tractor with over horsepower.
Yeah, this means that,
Yeah.
the horsepower will reach to some points.
Yeah.
The price of the tractor is still going up,
Yeah.
but reach to some horsepower, then the
Goes.
price will go down.
Yeah.
Look at the expressions. You can, before you run the result,
Okay.
okay, you can see from the paragraph what he says, the dealer says, then you can imagine the situations.
Okay.
Therefore, we put the squared it to test whether the result follow with what the dealer say.
Okay.
This is called, something like theory. Although it is not really theory, but it is the practical experience. So with this practical experience, we want to use all the data to check whether follow this experience. That's why we put the square term on it, and to show that whether we really come out with this situation.
Okay.
So it doesn't mean that we run the result, we add the square terms, and we see the result. then we say this situation, this result, okay, it's really beginning from what this professional dealer say. So we wanted to show whether the statements from the experienced dealer is correct or not. Okay, so from reading what the dealer say, then we think we need to add the square term of the horsepower to check the result. You see what I'm saying? So this is the procedures for doing the research. It's not looking at the result to say something from the result, but according to the experience or according to the theory. You see what I'm saying here? So this is the sequence for doing the research. So the sequence for all these steps from chapter 3 is really, really important. The 6th step, right? If you follow the 6th step to do your thesis, then you won't miss any parts. Okay? This is really what we have learned from this class. Not just all this statistical package running, Okay, according to this theory, then we use the EVIUS to run all this result, and then you need to explain it. And what you explain it is really wanted to prove the theory. Okay? All right. Okay, then. So did you find these maximum points?
Yeah.
Yeah, okay.
Yeah.
Okay.
So according to what I learned when I was a kid. So,
okay,
yeah,
very good. Okay.
Yeah. So the point, the maximum. Yeah.
Sure.
the-
Thank you.
Yeah.
Very
so
good.
approximately the horsepower will equal to 363.
Okay, good.
And according according to the adjusted R squared, the one with the horsepower square has higher adjusted R squared. So I choose this one. Yeah.
Okay. Step number 4.
Okay. Step 4. Add the cap into the step 3, the result. Yeah.
Okay, why do we want to
Add
add the cap variables?
So according to the statement, it says if the tractor with a cap, it may be coming handy in bad weather. So it may have a positive relationship
Very
with
good.
the price. Yeah.
That's right. Okay, so we do add in these variables, then this is the result.
Yeah.
Okay, then say what you B parts.
B
Okay.
part. So the theory is like what I said. Yeah. And the adjusted R squared. The right hand side is the one with cap, and it has higher adjusted R squared. Yeah. And the third step is t-test. So according to the literature, the coefficient of cap has positive relationship with price. So we hypothesize this alternative hypothesis. It will greater than 0.
Okay, when you do your thesis,
Okay.
the
Beta something.
Beta.
Okay. Yeah. And this is the outcome I get. We reject null hypothesis because there is enough evidence to infer the alternative hypothesis. And the fourth step is bias. And yeah, it's the correct equation with cap. and the estimated is 1 without the cap, and auxiliary regression is the y will be the cap. Yeah, and this is what I get. Yeah. No, just one, the beta one for the horsepower. Yeah. 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 Okay, so step 5. Okay, joint hypothesis testing. Is partial F test. Yes. I forgot to write the A. Is yeah the one of the season disappear. Yeah, the autumn. Yeah. And the B part is write the null and alternative hypothesis. Yeah. And so this is what I hypothesize. And the C is the constraint equation. I refer to the textbook. It means the equation when the null hypothesis is correct. So there I don't have, I did not add the constraint equation. Yeah, constraint equation. Yeah. And the D is the partial F test I got. I use the redundant variable test. Yeah, because I forgot how to. Yeah. And so, and this is the result. We do not reject null hypothesis. There is no evidence to infer at least 1 beta j not equal to 0. So we will set the tractor do not have a seasonal pattern. Yeah. And step 6 is we need to create a slope dummy variables. So I add this one additional hour. I use diesel times engine hour. Yeah, and this is the result I got. Yeah, and I do a t-test, and the result is we do not reject null hypothesis. There is not enough evidence to infer alternative hypothesis. So it means additional hour should not be added to the equation. Yeah, okay. Yeah, that's all. Thank you.
Testing. Hello, I'm Harry. I'm going to present the assignment 6. Here's step 1, we fill the literature. And we start step 2. Here is the output in the e-field. I go down. And part B. Adjust R square is 0.697. It seems to me that it's reasonable because the more variables in the regression, the higher adjust R square we got. So
The more variable in regression, the higher. Just the R square, is that right?
I'm not sure, but
Well, the more
relate variable in the
Well,
regression.
in fact, the more variable in regressions, the higher R square is, not adjust the R square.
Oh, I made a mistake.
Okay, although you put the nonsense variables in the equation, the R square will increase, but the increase very little.
Okay.
It still increase.
Okay.
Okay, so this is not quite right. Okay, this statement is not quite right. Okay, all right.
And part C, I know all estimate coefficient are expected.
Okay, all right.
And part D,
Okay, just say it. Just say one.
would say
Name one to do the presentation.
name what?
Just use one variable. You can choose any one of them.
Okay.
What do you want to choose?
Horsepower.
Okay, all right.
Yeah. The critical value is 1.645, and here is the output.
What? Why it is 1.60?
Critical
45?
value? Because
How many observations do we have
the
for this data? How
the
many
f-
observations?
Hmm?
How many observations of this day?
You
Huh? Let's see your output.
output. Okay.
How many observations do we have?
Observation. I don't understand.
You don't. Okay.
no.
How many sample size do we have? 275,
Yeah.
right? Okay, so you're using one. This is alpha for 5%.
Yeah, alpha for 5%.
Okay,
Mm.
so,
So critical value, and I checked the table. Critical value is 1.6.
okay, it should be positive or negative.
Positive.
It can be positive or negative,
Yeah, yeah.
right? It really depends on the site of the
Mhm.
test, okay? So you're choosing horsepower, which is the positive,
Yes.
all right?
Yes.
So show the horsepower test.
And the horsepower is 15.615,
Mhm.
and here is bigger than critical value, so we reject the hypothesis.
Mm-hmm.
Okay, and I go down,
Okay.
and this
Well,
yeah.
Well, look at this one, okay? I want to show you these parts, okay? And although our textbook tell us that use the absolute signs, for like something like this one. Okay, because the author wanted to explain both ways. Therefore, they have to use this one. Okay, but if we want to test one-sided, we already know the direction. Do not use this one.
Okay,
Okay, you will make mistakes.
what kind of mistake we make? I will make.
If this one the sign of this one should be matched with this one. That would be correct. Okay, so like number 6. Okay, let me see the number 6. It's positive. This is negative, right? This one? Is this one? Number 6 is this one?
Mm-hmm.
Okay, so this is negative sign. So the t-test is negative 1.57, right? Okay, look at the negative 1.571. Okay, if you do the absolute sign here, is this one greater than this one? Is this one greater than this one? If you put this one, right? Is this one greater than this one?
No, so I do not reject.
Okay. For this case is, okay, then the correct things is you do not put this absolute sign here, but to put the negative sign here, because the critical value is this. You see what I'm saying here? the critical value is negative. Okay? Since the author wanted to explain both ways in the same statements, therefore they use this one.
Oh,
But since you
one
already
side.
know the directions,
Okay.
okay, you need to tell us that critical value for negative sign is negative 1.645. Okay?
Okay.
So if you take out this absolute signs, then say this one is greater than negative
Okay.
1.645, then do not reject it.
Okay. So both sides need to this one side we don't use it.
Both sides, you can use this
Okay,
one.
okay, okay.
But for one direction, one-sided, do not use this one. You have to use this one to tell whether you compare with the negative critical value or positive.
Okay.
Okay?
Sorry, my bad.
All right?
And
I think this is very important concept. Okay.
in the conclusion, all the non-hypotheses are rejected except except the mineral variable. And part E, for the each tutor made by John that the sale price of the trader will be increased by 17% by holding other variable as constant. And step 3, okay. Oh, yeah. Part A, just one the new regression. Also, cost 5% one side, the critical value is 1.645, and here is
What do you mean by horsepower square equal to beta 1 square?
wait. The horsepower square. How?
Huh? Go down.
Put that. Okay.
Yeah. What do you mean by horsepower square equal to beta 1 square? What does that mean?
Oh. I mean, okay.
You should say horsepower square equal to x1, and horsepower square is x1 square.
X1. Oh, X1. Yeah. No.
It's not beta 2
Yeah. No
or
beta.
beta 1 square.
Mm-hmm.
Okay?
My bad. Yes.
Okay.
And I go down.
All right.
For the horsepower, and we reject the hypothesis, and the horsepower square we also reject it. And part C, this formula also from the textbook, and I just put the number in and got this number, yeah. And yes, a maximum number. For part D, I would prefer the polynomial equation because it more related static and logic and than the base equation. And there are 4 criteria to prove polynomial equation are better. Polynomial equation are better. And step 4 also we run the.
But you didn't show the 4 criteria.
On the this
okay.
on this step. So just
All
one.
right. All right.
Part B, I just mentioned the four
Okay.
critical.
All right. All right.
The first one is adjust R square from the. I think I make the same mistake. Adjust R square should not change.
This is.
Hmm?
Did you use adjusted R square?
Yeah, first
Yeah.
one.
Okay. Okay.
And the higher the better. I made the
Yeah,
same
yeah.
mistake in the
Okay.
step one. And the lower the better is the AIC, BIC, and hand cream. It also decreased. So all the critical show that at the CAB we will
Okay.
increase the relation between sales price and the mode. For step 5, they are missing autumn season. The seasonal mode should be 4 seasons.
Okay. Just go on to
To
D parts.
the part. When the F test,
Okay. All right.
yes, is output
Alright.
in the review. The conclusion is do not reject hypothesis because critical critical f f value is more than critical value, so we do not reject. Is
Okay.
that correct? Yeah. Here.
How did you get 1.83?
1.83. Oh, check the bill. Here. Yeah. Oh, yeah. Check the bill. Check the table. Check the table.
From tables.
Yeah.
Okay.
Yeah.
All right.
My conclusion is the trader price has no seasonal pattern. Step 6.
Hey, excuse me. Let me see your F value. 1.83.
Is that correct?
Where did you get this? 1.83.
Mm-hmm.
Where did you get 1.83?
I checked the one table.
Degrees of freedom from numerator. What's the numerator's degrees of freedom right now? Actually, you can see the probability.
Probably.
Okay, you can see from the probabilities, but you wanted to do the critical value approach, right?
Yeah.
So you need to find the correct critical value, and what is the critical value? You need to find it from here. What is it? How did you locate 1.83?
I think I may find the wrong number.
From what number? From tables. Okay.
Yes.
If you want to see from F tables, you need to know the degrees of freedom from numerator and denominator. What is the numerator here? The number of numerator from this is already there. 3, right?
Yeah. Fee.
Okay, so if we, and what's the alpha level here?
Alpha level.
Do you have book with you?
No, I use textbook.
Okay, use my tables. Use my tables, okay? Everybody look at this one. This F statistics with 3 degrees of freedom in the numerator, right? And we have alpha level is 5%. So what is the critical value?
%.
It's 3, right?
C and
And since we have 265, which is larger than our
120.
tables, right?
yes.
So you may see this 120, or it's not really big difference. Usually I'll see 120 instead of infinitive because 365 is more close to 120. So the number is 268.
2.68.
instead of 183.
Mm.
The 183 you are looking at
Is
is
one number.
10.
Mm-hmm.
This is original. This is just partial F test. Okay, although we have 10 variables in the model, but we're checking with this partial F test using the partial F test numerator's degrees of freedom, which is 3. Okay?
Okay. I
Okay?
got it.
So if you want to do the critical value approach,
Mm.
you need to find out the correct critical value. But here, you can just look at the p-value. But according to these two criteria, they all do not reject the null hypothesis.
Mm.
All right?
Okay. And step 6, add the slope dummy in the regression.
This is my book.
And here is the output. Mm. How to expand? I don't know how to say it.
You don't know how to say that?
Yeah.
Why?
The I add a variable. This one is DIE times n hours.
How to call this kind of variable?
Huh?
How to call this variable?
This slope dummy.
Slope dummy variable.
Slope dummy
Oh,
variable.
Okay. Then
And
your
the
expectation, according to the questions, the expectation is
Higher than positive.
positive.
Yeah,
Okay.
positive.
Then
Then the critical value is 1.645 and called a T value is T value from the some slope
from the output,
from the output.
look at the output.
Okay, from
You
the
have
output
0.377, right?
And we do not reject the.
How come you change your critical value to 1.684?
I mean,
Actually, it's 1.684
yeah.
instead of
I
1.645.
forgot. Okay.
Okay, but we really don't care that much about this larger degrees of freedom in the denominator.
Mm.
Okay,
Wow. And
so do not reject. What does that mean?
do not reject. What's
What does that mean?
slope bit.
You finish?
Slope dummy variable. Hmm. I don't know.
Well, do not reject means what? The dummy variable, a slope dummy variable is not significant, right?
It's yeah. It's not. It's not
You finished or not finished yet?
finished.
Finished, but there's no conclusion.
Oh.
Do not reject doesn't mean a conclusion.
Mm. Or the conclusion is not the variable is not significant.
It's not significant.
Okay. Oh yes.
Okay.
got it. Okay.
All right. All right. Thank you.
Thank
Thank you. Then, Leticia. How do you pronounce this in Chinese? 没有 huh? 妹 or 没不知道哈妹 maybe 妹
I don't know the tone.
Oh, you don't know the tone. Okay, we have 4 tones. Chinese has 4 tones. There are 4 tones. Okay. How many tones in English? No tones. Well, just intonation. You know, you really have intonation, right? But intonation is different from tones. It's different? I don't know. Well, okay. Okay, just do the E parts. Let me see the output and do the E parts. Okay? A, B, C, D, E. Yeah, okay. Any signs?
This one is the coefficient of John Deere is 0.172534. So it means that if the tractor is manufactured by John Deere, then the sales price will be increased by 17.3%, holding constant the other variables.
Okay, all right. Step 3, C.
Step 3C. Yes, this one is the result.
Mm-hmm.
And this one is the derivative. The derivative is the slope.
Oh, how do you draw this diagram?
Uh,
How did you draw that?
just copy it.
Copy it. Okay.
Yeah,
Alright.
the Y one is the sales price, the lead sales price, and the X one is the horsepower, holding constant the other variables.
Mm-hmm.
And as we want to know the maximum value,
Mm-hmm.
and then we
How come yours is 3.60 something? Usually it's 3.62
I think
something.
because of the
Decimal
decimals.
places?
Uh-huh. Yeah, because if I add
It-
0.05 15008, I think the result will be
You know,
362.
in the math parts, okay, according to the math,
Mhm.
okay, as long as you can use, since you are working with the calculator or something, as long as you can accommodate many decimal places, just use as many as possible.
Oh,
Usually
okay.
it's in that way. But if we do the writing, okay, sometimes we just use 2 decimal places or 4 decimal places. But if you have, usually there's some difference on it.
Yeah, yeah.
Okay, it doesn't mean that this number is wrong,
Yeah.
but it's caused by decimal
The
places.
yes, right.
But in math points of view, as long as you can use as many as decimal places, use it.
Oh, okay.
Okay?
Okay.
Since we don't use that by hands, right? Just
Yeah.
use computers.
Oh.
So let the computer do as many
Numbers.
decimal places.
Okay.
Okay? All right?
Okay, sure. So,
All right.
okay.
The D.
The D from the adjusted R square, the polynomial equation is the result of adjusted R square is higher than the basic equation. Therefore, after adding the squared horsepower, it's indicating that the variable is relevant and worth adding into the equation. And it also the same from the result of AIC, BIC, and the Hanan-Quinn result. From those value, the polynomial equation, the result is decreasing. Therefore, we can conclude that the square horsepower variable is worth adding to the equation.
Okay.
And based on those results, we prefer the polynomial equation.
Mm-hmm. Okay, step 4.
Step 4.
B.
Step 4B. Yeah, this is our equation, the result.
Mm-hmm.
And the 4 criteria, we skip the theory part because we think that the theory
Alright.
is correct. And then the second one is the adjusted R square.
Mm-hmm.
From this result, the adjusted R square from the second equation model is higher than the first equation model.
Okay.
Therefore, it's indicate that the cap variable is relevant and worth adding into the equation.
Mm-hmm.
And from the t-test, we got the result that to reject the null hypothesis as there is enough evidence to infer the alternative hypothesis. So it means that the cap variable is significant. And from the bias, from the two equation, we can see there's some slightly change in the other coefficient by adding the variable cap, which indicating that there is a bias in the original result.
Okay.
And this is the other criteria, and
Alright.
the result of the second equation model is lower compared to the first equation model.
Mm-hmm.
So based on those tests above, it shows that the cap variable is statistically significant to the sales price and worth adding, and should not be omitted from the equation.
Okay. Step 5.
Step 5,
Alright.
it's the same for the A,
Mm-hmm.
and this one is our null hypothesis and the alternative hypothesis.
Mm-hmm. Okay.
And we do the wall test and also the redundant test. So this is
Oh,
the
okay.
result.
Okay, you also do these parts. Okay, all
Yeah.
right.
So we compare the
Mm-hmm.
F statistic from the EViews, and our calculation
Yeah.
is the
okay.
same.
Very good.
And then from the critical value approach and the p-value approach, we got the result that do not reject the null hypothesis, as there is no evidence to infer the alternative hypothesis.
Mm-hmm.
So our conclusion is the use structure price have no seasonal pattern.
Mm-hmm.
And for the last step, the step 6, the slope dummy, we want to see the interaction between diesel and the engine hours. Therefore, we multiply the engine hours with the diesel.
Okay.
And this is the result. Again, we use the critical value and p-value approach
Okay.
to see whether it is significant or not. And the result is do not reject the null hypothesis, as there is no evidence to infer the alternative hypothesis, which means it is not significant.
Okay.
So the conclusion that we could not reject the null hypothesis of no difference due to the fuel in the impact of
Yeah.
engine hours on sales price, holding constant the
Okay.
other variable.
All right. Thank you. By the way, I see you several times. Do you know how to put the numbers on each page? You don't know how to do that? Okay. All right. But I never see students do the number when you turn in these assignments. Okay. This is already last last one. But if you turn in your assignments, make sure to make the page mark on it. Usually we need to do that. Okay? All right. And very well. Very well. Okay.
Hello, good morning. So similar to what the others have already shown, these are the hypothesized sign of coefficients for the independent variables of our structure price model.
Okay. Okay, just do the E parts.
Letter D, sorry.
E.
E.
A, B, C, D, E.
All right. For E, holding other variables as constant, if a tractor is manufactured by John Deere, there is 17% increase in its sale price. A tractor's price depends on its shape, size, utility, and technology. And since John Deere is the top manufacturer of agricultural and turf equipment globally, it only makes sense that its tractors would have slightly higher price than its competitors. For step 3, we compared the variables by adding the squared horsepower. So for this part, we can see that when we run the critical value approach, we reject both, as there is not enough evidence to infer that it's greater than 0. And then for this part, I also computed it the same way as others, and we have come up with 363. So at 363 horsepower, a tractor reaches its maximum value. Graphically, it would be an inverted U shape. So comparing the polynomial and the basic equation, as we can see, the basic equation have the polynomial equation have lower AIC, BIC, and Hannon-Quinn values, and it has a higher adjusted R-squared value. So based on this, the polynomial equation is better than the basic one. So for the step 3, we add the CAB variable. For the theory, there's an added benefit if you have enclosed cab. So it seems reasonable that it would be reasonable to it would have effect on the price. It's reasonable to add it in the regression model. So checking for the t-test, we
Are you checking with the alternative hypothesis -0? Is a negative sign?
where? What do you mean?
This
I'm
is
sorry.
for cab, right?
Yes.
Is
This is the expected sign is positive, so we're looking at the right-hand side of. That's why our expectation is it should be greater than 0.
yeah, it should be greater than
Yeah.
0, right?
Yeah,
So
and then
you put the negative. Less than 0. You should be greater than 0, right?
yeah. Yeah, I'm sorry for that.
Okay.
But we reject it as there is not enough evidence to infer.
Okay, all right.
Sorry for that. I just copied it from the above. Okay, so for the adjusted R squared, without cab, it's 0.764. With cab, it's 7.99. So there's a slight increase. So we could say that adding the variable cab increased adjusted R squared, and it indicates that the cab was an omitted variable. For the bias, all coefficients of other independent variables increased when cab was added in the equation. So it may suggest that there is bias caused by omitting this variable. Then for the AIC, BIC, and Hannon-Quinn values, we could see that there is lower value for the model with cab. So we can say that it is a better model.
Okay.
For step 5, joint hypothesis, yeah, the omitted season is autumn or fall. As I have seen online, autumn is harvest season for most crops, so this means that it may be an off-season for tractors.
Okay.
And then this is my null hypothesis. Beta 8 is equal to beta 9 is equal to beta 10 is equal to 0. And at least one beta j which is not equal to 0, j indicating 8, 9, or 10. And then this is the constraint equation. And then I also did the partial F test or the Wald test. And did the critical value approach and the p-value approach. So based on these results, we do not reject, as there is not enough evidence to infer the alternative hypothesis. Based on the results, I therefore conclude that tractor prices do not have seasonal pattern. So for the slope dummy, we just added the slope dummy variable of diesel multiplied to engineering hours. So using the critical value approach and p-value approach, we do not reject, and there is not enough evidence to infer the alternative hypothesis. Therefore, we conclude that the additional hours do not have significant effect on the value of the tractor.
Okay, okay. Thank you. Thank you. Then, Daisy.
Hi, Professor and everyone. This is the sixth assignment, so the step one, we skip it. The step two, we have the PACES model, and this is my result from eView. And the equation, and on the the value is meet my expectation. Next one.
We'll do the D parts.
D part.
Choose any one of the variables to do the hypothesis testing.
I choose the first one,
Okay.
horsepower,
All right.
and I do it by t-statistics. We set up the level of significance if 5%, and then we take some number from the eView result, and then we have this one. From this number, I took it from the book at the last one page, and then we compare it based on this rule, and we have reject x0. Okay,
On to the D parts.
E part, yes, this one.
Yeah, E parts, please. Sorry.
We have, we are supposed to be that the product manufactured by John Deere is 1 and or not, it would be 0, and it means the sale rate will increase about 17.25%. In our reply, we can see that the real should be a trusted brand, and most of the people decide to buy the product based on the brand name.
What do you mean by if the tractor of John Deere increases by 1%? What does that mean?
Sorry, it's not correct because
What kind of variable of John
it's
Deere?
a dummy variable, so
Yeah.
it's not correct. I type wrong.
It means that if the tractor of
It should be not increased by 1% here, so
Yeah.
it should be deleted here.
yeah, all right.
And
Then go on to step 3.
step 3.
Explain the B parts, okay?
P part.
Mm-hmm.
Yes, the P part we run
B
the
parts just for power.
Mhm.
The coefficient horsepower squared. Do B parts.
P part. Yes, we run
No, not this one.
this one. Yes, the
Step 3.
step 3
Yeah.
P part here.
Step
and-
3 B parts.
Yes.
Okay.
We run the eView for horsepower and square horsepower, and we also do the t-statistics, and then we have after doing the by critical value approach, we have the result that we will reject for both of them, and then I have the
For the square terms.
square
Yeah.
horsepower.
Yeah,
here.
the square terms.
Yes, and
What is the alternative hypothesis here?
sorry, can you
The
please?
alternative hypothesis. Alternative hypothesis. What did you write it for your alternative hypothesis?
Negative here, right? It's
Alternative hypothesis. Go down. Go down.
go down,
Well, go up. Go up.
go up,
I'm sorry. Yeah. Alternative hypothesis. What did you
okay.
write?
stay.
This is for square horsepower, right? So what is your now alternative hypothesis here?
It is where horsepower and wait me a minute. Sorry, I don't have idea to answer it.
Okay, so what do you have to say for your now alternative hypothesis for horsepower?
Hypothesis for horsepower. I just do it the same way.
The same way as the horsepower?
before.
The same way as the horsepower?
Not is the same way because it's we have two sides, negative and positive, and the horsepower, the normal horsepower is positive and this one is negative.
Did you see from the result to decide the size of your coefficient?
This one is from the result from EView. And
Yeah, I know it's from eViews, but do you do this one because of you already see the output?
No, because when I have the result negative here, so I put the negative here too.
So what is the alternative hypothesis? Do you understand what my question? We are working with, look at this now an alternative hypothesis.
Alternative.
We're looking at horsepower square, right? What do you have to show now an alternative hypothesis here? You put it beta 1, right? Actually, it's beta 2 instead of beta 1, right? Beta 1 is for horsepower instead of the square of the horsepower, right?
Yes.
So what you should write it down here for the now and alternative hypothesis.
This one. So it's mean.
No. Step one.
Okay. So
Beta
should
2.
be beta 11 here.
Beta 11?
Yes.
Oh.
Just my.
Oh, it's 11? And what is the horsepower? Let me see your output, okay?
Output.
Where is your output for the horsepower square?
Square horsepower.
Output.
Okay.
Yeah, here.
Yes, the horsepower.
So horsepower is beta 1 and
yes.
horsepower square is beta 11.
Yes.
Okay.
So-
Then,
Yes. It should
so what
be
is your now alternative hypothesis here?
none? So it is beta 11 here,
11. Then
and also 11 here.
Is
Also here.
Is this is right? Is this? Is the sign of this one is right?
This it should be smaller.
Why it should be smaller?
Because it's negative.
Because you see the output is negative. So
Yes.
no, that's wrong. That in step 1. Your result in step 3. So explain to me why it should be negative. You don't know.
I don't really know about it.
Okay. Then
So-
go on.
Okay.
Go on. Go on. Step 3. Okay. Then C parts.
Step 3, C part.
Step 3. C parts.
Yes. Okay. Here.
Okay.
And the equation here is from the book, and we also take the number from the result of EView, and we
Okay.
put here, and we make some calculation, and we can figure out x1 is 362 point blah blah blah.
How come these two numbers different?
Okay. Yes, it's different.
Why? Why it is different? Well, which one is correct?
when I calculate it, I do it by the calculation in the computer. In
Okay. All
yes,
right.
so it's hard to do
Okay.
by manual. So maybe I
Mhm.
copy wrong here.
Okay.
So
okay.
one of the two. The
All right.
okay.
So D.
So part D, we have the
Mhm.
comparison between basic equation and
Okay.
polynomial equations. We,
All right.
So from two results here, we also see that there is an increase between the R square and adjusted R square. So I think that it could be use the polynomial equation because looks at the result it's not insignificant change, but it's look more accurately
How do you know whether it is significant change or not?
because it's increased but not too much.
What do you mean not too much?
I think about
8% is not too much.
69 to 77.
8% is not big enough. How do you know?
Because just think
Just increase. Just increase. We didn't know whether it is significant or not,
Okay.
but just increase. Okay.
Yes.
All right. Step 4.
Step 4. The cap. From the step 4, we need to add the cap
Okay.
to see this one.
Okay.
Yes. And the equation here is
Mm-hmm.
next to the part B. For this step, we have two results. One of the which I call which the first one is this one, and the two one is we add after we add 3 season.
Okay.
After we add the cap
Mhm.
into the class one.
Okay.
And in theory, we have insist that the sale price should be impacted by the cap. If the tractor has a cap, the cost of the tractor will go up based on the statement on the book.
Mm-hmm.
And then we also do the T statistics here
Mm-hmm.
by critical value approach, and we have reject the S0 here.
Okay.
From every and from our regression result, we also have two different results for adjusted R square, 0.76 and 0.79, and we saw that after we add in the cap and run EV, we see the adjusted R square is higher. I think it's a good influence for the sale price. So we have the conclusion that we should add the cap into the equation to have more detail in result, but it still not affect many things into the other variable. Yes, and let's move to the step 5.
Step 5.
Yeah. The omitted conditions in this seasonal model is autumn because
Mhm.
we have 4
Okay.
seasons here, and the noon and alternative hypothesis is this one.
Okay.
I write out here, and this is the result from EView equation here. For the part D, we also do the F test, partial F test.
Mm-hmm.
We have 276 number of observation, and we can calculate this number.
Mhm.
Also, we can do by the
Okay.
function here, and also have this one. But when we run the EView, we have the quite different result.
Quite different.
No, different, but it's not too much. It's very small. This one, because I saw that in Gradle, Zoom do it it had the same result with this one. And in eView, I run it, it had this one. So, but I use eView almostly, so I use this number
Okay.
to compare. And this number, I take it from the book. And we are,
Check it from book.
yes,
2.6.
mm,
I think we just check it, right? Is it 2.6?
2.6
Let
for
me see.
the app, this
2.6.
infinity something.
3 variable. Oh, you are using infinitive. Okay.
Yeah.
But okay, all right.
So we have do not reject.
Okay.
Also the same result with the p-value approach.
Mm-hmm.
And so that our conclusion is there is not enough evidence to infer the time of the year's no effect on the price sale.
The time of the year
Yes.
has no effect.
On the price sale price of the tractor.
What do you mean at the time of the year? Okay.
Because I saw from the textbook, the question is had this statement, so I just copied
Seasonal pattern.
season
We didn't
of,
say time of the year.
season in the, years.
time of year of the sales has no effect on the price of tractors. Okay. Okay, all right.
And the,
Especially this is for seasonal effect.
yes, season of the year.
Seasonal
no
effect.
Yeah.
Okay? All right.
The last one is
Step
we
6.
consider slope dummy to interact with the self and
Yes.
do,
Okay.
also do the t-test statistic
Mhm.
and do not reject, and then we conclude that there is not enough evidence to infer. And also additional hour of use doesn't affect value of the self. That's all.
Additional hour of use.
Doesn't affect to the value.
What kind of variables is this one you're testing? How do we call this variables we're testing right now?
The slope dummy.
Slope dummy variables. Okay? Okay. All right.
Okay.
Thank you. Thank you. Well, the last one. Where is gonna be here? 35. Yeah, here. All right. Make it larger. Okay.
Hi everyone. This is my assignment. This is the literature, review the literature, and this is the basic model. And
What is this output?
Mine
What
was,
kind of this output?
Mine laptop was. I said
Huh?
to you last week that my laptop's display was gone, so I was using my friend's one with the help of him. So it was Gretel.
What kind of this?
Gretel.
What kind of this output? From what package?
Gretel.
From Gretel's?
Yes.
Okay, would you run a Gretel for me?
This one?
Yeah.
This?
Since this is the running from Gretel's,
Yeah.
and you're saying that your computer doesn't work for eViews,
Yeah, I just used
Yeah,
the
so
help
run
of my
the-
friend.
run Gretel for me.
I just
Run it.
I know the use, but this one with the help of my friend I did that.
But how come your report, the assignment you turn in is using eViews? The past 5 assignments you are
Yeah,
doing
yes,
using
yes.
eViews, but this one is
Yeah, that's what I
Gretel.
told.
So
that's
can
what I
you
told
run
him.
the eViews?
Yeah.
Okay, then run the eViews. No, using the computers.
Okay.
Run eViews for this project. this off. This one? Well, we have eViews here, right? So run the eViews, okay? All right. Let me get it. Let me see. Where is my, oh, this one? Well, I have this data set, right? Okay, here. Let's see here. Okay, this is the run the basic model first. Is this the basic model in step 2? This is your result. You run it, right? Okay. Turn on this one. Okay, then double check with your result. Well, no. The one you just run from the eViews. Okay, then turn it on. Let me see. This is the one you run it, okay? Then turn this one on. Okay, let me see. Yeah, okay. Good. Okay. Okay, this one. Do they have the same result? First of all, is there any cap here? I think the most important one is what is Y variable? Huh? Sales price, right? Do you use sales price here? What's our Y variable? You're using sales price, but actually, the question say that we need to do the log price of the sales price, right? So what you are running from the eViews is using sales price instead of log of the sales price. Do you understand that? Okay, then generate log sales from eViews. Yeah, from eViews. This is original sales price. We need to generate it as a log sales price. Huh? There's one here. This one. Then name it. Name the log sales price. No, just change it to English. Change it, yeah, that's okay. Give the new name for log sales price. Sale price. Look at this one. Okay, now you can do it. Yeah, name it. You can name it by yourself. You cannot use the same name as the. You cannot use the same name as the old one. Then use the same name as this one. This is equal. Do you know how to use the eViews? Huh? Okay. Equal. Yeah. Let me see. Equal sign. Then use the same name with this one. Okay. Okay, this one, okay. Yeah, you have this new Y variable. Okay, then run the basic model. John Deere. Then No, 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 we don't have cap. Summer, winter. Then run it. Now you have this one. Oh, you create. Okay, turn in the assignments. You just did it. Okay, explain this one. So it looks like your working EVIUS is just a new hand. We have done 6 assignments, and it isn't, it seems to me that for you, it's really new. Okay, explain it. B parts.
Here the R square seems reasonable by the sales price, by those variables.
Just need the book.
With 69%, like you can see here in R square, it's 0.69, and the estimated coefficients do not have any unexpected signs. And when we are running the 5% t-test, it's like
Okay, explain this one. Hypothesis testing.
yeah, hypothesis testing, null hypothesis and alternative hypothesis, and taking the level of significance as 5%, and T1 and beta 1 by standard error, we will get it's like this one. It's the critical value, and we are using the critical value approach to take the decision to whether to reject the null hypothesis. And with enough evidence, we can infer that
How did you get 1.65062
it's from the textbook, from the book.
from textbook? Show me. Where you can find it from textbook?
Table.
You mean the table?
Yes.
Oh, let's see the table. Did you see 1.65062?
Critical value. Where's the table? Which table?
Huh?
That one, right?
No, we don't. We don't have these numbers from textbook. Just tell me, where did you get those numbers from?
Currently blank.
Did you do all this homework by yourself?
With the help of a friend.
Huh?
The help of friend.
You had it from your friends?
Help.
You help with your friends? Who is it?
Senior.
Huh?
Senior.
Huh?
Senior.
Okay. Then, it's also good to get help, but you need to understand what you're writing.
Should be that's right.
explain it, the E parts.
So, the price of the tractor will
How come this answer is really the same as Daisy's? We just see this one, right? If the tractor of John Deere increases by 1%, the price of tractor increased by... Okay, explain this one. Explain this one. Explain E parts. Okay, you can have a sit. Maybe it's easier for all of you.
here coefficient 10.
Okay, how to explain this one? How to explain the meaning of 0.1725 something?
If it is increased by 1% by holding constant. the
Excuse
other-
me? Huh?
If the price increased by 1%,
Huh? If what?
the beta something increased by 1%, it will.
What increased by what? I don't hear you. What did you just write?
Huh?
What did you just write? This is your assignment, right?
Yeah.
This is the assignment you wrote, right? What did you just write? What does that sentence mean?
I think if John Deere tractors manufacture with, then the price will be increased by this percentage.
Say it again. I'm sorry. Really didn't hear that quite clear. Well, stay here. What does this sentence mean? You wrote it by yourself, right?
Yeah.
And what does that mean? So let's skip this one. We'll come back later, okay? Step 3. Step 3.
Yeah.
Step 3.
Generate a new variable and run the new regression, and I used
Okay? Do the B
Horsepower.
parts here.
horsepower as the variable, and null hypothesis and alternative hypothesis, and take the significant level of 5% and run the t-statistics test, and we got the value like this one. and to take the decision whether to reject the null hypothesis, I used critical value approach and p-value approach. And for the critical value approach, it's concluded that reject null hypothesis, there is enough evidence to infer the alternative hypothesis. And for the square of horsepower, it's the same, and taking the 5% significance level.
Well. Stay here. This is for squared horsepower. What do you mean by your alternative hypothesis? Why do you want to do the negative less than 0 here?
Oh,
I mean, the alternative hypothesis, why it is,
it should be the other side.
huh?
It should be like this, the other side.
It should be like what? Greater than 0? What does that
Can I-
mean? I mean,
May I know
what
your
does
question,
this alternative hypothesis mean?
please? Alternative hypothesis means the values which the researchers expect.
Then why do you expect negative?
I think it's mistake. It should not be negative.
Huh?
It shouldn't be negative. It's mistake. I think so.
In the negative 0, negative is wrong? No, my question is, what this alternative hypothesis mean?
The values which we expect.
So you expect it is negative, right?
Yes.
Why do you expect it is negative?
From the reviewed literature review
Huh? From what?
from the review of the literature.
From, excuse me, from what? Why do you want to make it as negative or alternative hypothesis here?
It is what we expect,
And why do you expect the negative?
because if horsepower increase, the price will go down.
Then
Then it will be negative. The relationship will be negative.
should be negative. Okay, then go on. Did you have this result? Did you find out? Did you find out it is the same result as you expect? Does this hypothesis testing support your expectation?
I think it reject the null hypothesis. So I think yes.
What do you mean by rejection rule for an upper toe test? Upper tail, okay. Upper tail test. What do you mean by upper tail test? Since it is negative, go on C parts.
Equation from the textbook and put the values in it, and it will have the maximum value of 362.408, and it is the maximum value of horsepower the tractor can reach. And preferring the polynomial equation because it provides the best value, and the r square from the basic equation and to the polynomial equation we can see the difference. For the polynomial equation it is 0.76, which is higher and accurate.
Okay, step 4.
Add a potential omitter variable, and here we use is cap.
Okay, then
The theory part and the t-test. level of significance 5%, and we will get the
Why-
value.
What's the meaning of alternative hypothesis here? Why it is greater than 0?
Because it's a positive relationship. Because if we use the cap, that rise of the tractor will increase.
Uh-huh.
So the alternative
So therefore,
hypothesis
it's positive.
should be positive.
Yeah, okay, go on.
For the critical value approach, we reject the alternate null hypothesis, and for R square is getting higher, and by comparing those there is no bias, so that there is no significant changes after comparing the both regression models. The omitted seasonal model is here is autumn, and running the partial F test and using the level of significance as 5, collecting the doing the F test.
Okay, explain this one.
The residual mean of some square of the constraint equation minus the basic equation divided by m
Mm-hmm.
by residual sum of squares, n minus k minus 1, n total number of observations, and k the independent variables minus 1, and they will get it like this: 84.7775 by 8. And to take the decision, we use critical value approach, and here we can infer that to reject the null hypothesis with the enough evidence to infer that's alternative hypothesis. And
Well, excuse me. I thought this answer is really different from what we have it before. Let me see the upper one. Well, I think the F statistics we have is 1.01, 1.09, right? It's not 84 something. What is it? Well, this number is really different, right? Okay, let me see. Go on. Then p-value.
by making the conclusion, we reject the null hypothesis with enough evidence to infer that.
Well, all of our answer should be no seasonal effect. But your answer is season. What, in my opinion, the used tractor should have seasonal patterns. Something wrong with this. Something wrong here. Our answer is without seasonal patterns. Okay. Step 6.
Considering a slope dummy, and this is the t-test for and stating the null
What is your
hypothesis.
slope dummy variable? Where is it? Which one is slope dummy?
This one.
Is okay. How did you get this one? How do we define the variable of the a slope dummy variable? How do you define that? Using,
The graph.
huh? Using what? What's the definition of your slope dummy? The dx is your slope dummy, right? And what's the definition of it?
The value of diesel tractor different from the gasoline.
Excuse me? Say it again.
The value.
Say it louder, okay?
The value of diesel tractor differing from the gasoline.
Times the gasoline. So which one? Which variable? Using what variable? So dx here is equal to what variable times what variable? No, your notation is just dx. You didn't say anything about the dx. So actually is what variable times what variable? Okay, explain it, explain it.
We're doing the hypothesis testing, null and alternative hypothesis, and using the level of significance as 5%, and doing the test statistics 0.37, and to make the decision whether to reject, we use critical value approach, and then we do not reject this null hypothesis because there is not enough evidence to infer the alternative hypothesis.
And what does that mean?
Because the value we get is greater than this one, 0.37.
And what does that mean? What do we mean by do not reject the null hypothesis?
Do not reject means the null hypothesis is right.
So what do we mean by null hypothesis right?
Because we cannot reject it.
You know, explain the language of this question. What does that mean? Okay, I'll read it by myself, okay? Thank you very much. Okay. All right, I think we already have review what do we have for this assignments. Then any questions about it? And anything what you want to say about this course, this semester? Well, I hope it's useful all of you to do the thesis, okay? Especially those concepts. I want you, all of you, to have very clear and cut. Okay, what we learned this semester. I think this is important for your thesis. Okay, and thank you for all the cooperation in this class this semester. Okay, nice to have you, all of you. Okay, thank you very much. So all right, so this semester is over. Okay, say bye-bye. Okay, that's it. We may leave now. Okay. And I'll give you as soon as all this grades. I'll turn in all these grades as soon as possible. Okay. All right. Okay. Does anybody want to take this another course next semester?
You do the econometrics class, right?
Yeah, econometrics.
Well, honestly, I thought about doing it, but having more free time.
Well, it's really up to all of you.
I don't have to take it. I could do it, but first I
Well, it's really up to you. It's really up to you. Okay? This is elective course. It's not required. Well, it's the less, yeah. Okay, especially for time series. You know, we are really focused on the cross-sectional data. But for next semesters, we have some parts is still cross-sectionals. There's maybe 60% for time series, then 40% for cross-sectional data to complete all the necessary.
Is that the reason I come to the class, but unofficially? I mean,
Is-
just here, I get like classics in the class and stuff.
You mean audit?
But like, yeah, not written on like just unofficially, right? Just for pleasure.
I don't think it's for pleasure. You know, if you want to audit, what do you mean is audit, right?
Yeah, probably. I'm not sure about the meaning of it.
I mean, you didn't enroll it, but audit, sit in the class. Well,
Don't do the assignments
no. If you want to sit in the class, do the assignments and do the presentation.
that's the plan, but maybe, because I will do the thesis all at once in the next semester, because I have like finance class I have to focus on.
Well,
So,
we all, yeah, I know, we all have many
yeah, sure.
excuses. Okay?
Also, I have the excuses, so that's
Well,
why I don't want to take too much responsibility.
well, you know,
I think the class content is very valuable.
well, I really wanted my students, if enrolled in the class, do the assignments just like this semester, and do the presentation. Without do the assignments and do the presentations, you don't learn. You don't learn it. No. If you wanted to sit in the class, do the assignments and do the presentation. Everything just like official students enrolled in the class. No excuse. No excuse. Okay? Then I'll welcome you to do that. Well, but you know, if we don't offer this class, then you don't have chance to audit in. Right? Okay? Well, it's really, your free choice. Your free choice. Okay? All right? Thank you all of you this semester.